Hello everyone and welcome back to the Game Engines course. Today we will continue with the second half of our Unreal Engine labs. And this means that starting from today you will learn how to develop multiplayer games using Unreal Engine. And Unreal Engine is actually quite a good engine for multiplayer games because it features a robust networking framework. So it has a lot of integrated tools and is kind of made for developing multiplayer games. And all those different components that we previously studied, like game mode, player controller, characters, spawns, etc., they are all made to work with multiplayer, and you get a lot of things out of the box. And even Unreal Engine own documentation suggests that if you're developing a game with Unreal Engine, you should always program for multiplayer, unless you are completely certain that your project will never need multiplayer features. And that's quite obvious for any kind of multiplayer games that you should start developing for multiplayer from the beginning. Because later on in the development process it gets much harder to add the necessary multiplayer features. But when you start doing it right from the beginning, whenever you add a new feature for a game, you will just have to make sure that it's also working with multiple players. Unreal Engine also uses client-server model, which means that one computer acts as a server and hosts the game session, while other players' computers are connecting to the server as clients. So there are the opposite version of it is peer-to-peer multiplayer. However, like Unreal Engine is this is not supported out of the box from the Unreal Engine, but for most of the games the client-server model will actually be more suitable. So you can make cooperative games, so you can make competitive head-to-head games. You can the server can be headless, and you can even make huge, large-scale, massive online RPG games, MMO games. So yeah. So a little bit about the client-server system. So as the client-server model suggests, the server is the host of the game, and it holds the one true authoritative game state. So server pretty much is the one that runs the game, and all the other players are synchronizing their states against the servers. And the clients each remote control pawns that they own on the server. So each client gets a player controller and possesses a pawn that he owns, and the pawn itself, he can send signals to the pawn, and the server is the one that holds the one true state of the game. And they send procedure calls to perform in-game actions. So the signals are called procedure calls in Unreal networking. So client pretty much sends information about its input, and server does all the calculations, and then broadcasts its own state and changes back to all the other players. So players are merely like simulating and approximating the state that's in the server. Server replicates information to each client, telling them what actors should exist, how those actors should behave, and what values different variables should have. So the actors, all the pretty much game objects in the Unreal Engine are called actors, as you remember, and the existence of those actors, the positions, the behavior is all kept in the server, and the process of sending it back to the clients is calling replication. And and there are different types of networking modes that you can have for a game. So the first and most simplest one that is a mode that you have already used is a standalone mode. So the game is running as a server and does not accept connections from remote clients. So it will run both server-side and client-side logic. So for example, single-player games or local multiplayer games, which means like couch co-op games, when both players are playing on the same keyboard or on the same computer. These kind of games are using the standalone networking mode. So you can still imagine it as a networking games, as the commands are still being executed. The networking commands, it's just that both the server and client side logic will run. It's like having a game where you're hosting your own server and you're the only player who's playing in there. Secondly, the mode can be a client mode. So in this case, the game is running as a client that is connected to a server. It will not run any server-side logic. It only gets the replicated state from the server and plays it back. Then the third variant is a listen server. This means that the game is running as a server hosting a network multiplayer session. It accepts remote clients and has a local player directly on the server. So the main thing here is that the server in this case is also one of the players. So this mode, for example, is quite suitable for casual cooperative games and also some casual competitive games where it's not too competitive, so that oftentimes the person who's hosting has some advantages. So games typically can limit the freedom of the clients. So clients' actions will all be validated, and also clients clients have a little bit more lag compared to the player who's also running the server, because the player who's running the server has the one true server state. He sees the most accurate vision. So there is a little bit advantage for the player who's hosting, because he can potentially use cheats. Because who's controlling the game? It's the host, it's the server, and he's running the server. So if he wants to, he can modify his game and cheat a bit. And also he has the best networking experience. So pretty much he should not notice any lag, while other players might have it. So there is a little advantage for the hosting player. So in case of listen server, one of the players itself hosts the game, Obviously, the advantage here is that the player who hosts the game can also when you as a developer, when you're developing game, then you can allow your own players to host their own servers, and you don't have to pay for server hosting. The fourth variant is using dedicated server. In this case, the game is running as a server hosting also a network multiplayer session. It can also accept remote connections, but has no local player attached. So in this mode, the game also it discards all the graphics, sounds, input, etc. Things that are not needed for running the security to provide better performance. So you can actually host or compile your game as a headless server and host it somewhere in the network and let other players to connect to this one your own hosted master server. So its benefits are, first of all, it's quite secure. Secondly, so it's secure. So all the players are equal against the server, and secondly, it can also support, like, if you want to make a very large scale massive multiplayer online game, like then using a dedicated server can be a better choice, because there are multiple reasons. Like, sometimes players are very might want to just log in and log off at their desired times. And secondly, so there might be a lot of host migrations otherwise. And secondly, when players are running the game as well, their computer needs to do a lot of additional work to process all the graphics and things like that. And this dedicated server can provide much more computing power for just serving the multiplayer. All right, so one main concept when developing multiplayer game in Unreal Engine is called replication, and this is the process of reproducing the game state between different machines in a network session. So that's the process how the host keeps all the players synchronized. And by default, most actors that you have in your game, we have already made quite many of them, they don't have replication enabled, and this will mean that they will only perform their actions locally without sending anything to the network. And you can actually quite easily enable it. If you open up your actor settings, then one section there is called replication, and you can just set the replicates true, and it starts replicating. Now, under this section there are some other parameters as well. So replicate movement is another one that we will I will tell you shortly, but so this will also allow to replicate the movement of those actors as well, not just the actor presence itself. There are also some additional things, like, for example, net load on client means that the client itself will automatically create this actor when the game starts. But and there are some relevant and relevancy options as well. In this course, we are not digging too deep into the relevancy system. It's because we don't need it. It's mostly useful for for larger type of multiplayer games. So if you're making just a multiplayer game where you have 4 people playing together, then you often don't even have to know about how this priority system works. But overall, why the relevancy system is there is that it allows the server to update some not server to update, but it allows to send like less data between the client and the servers. So if you're running for a large like a massive online multiplayer game or some battlegrounds type of game where hundreds of players are playing at the same time, then you don't want to like send send all the information about all the other players at every all the time. So when 100 players are simultaneously at the server and they all have to know about exact behaviors of all the other players, then it might get quite the bandwidth can be, the network bandwidth can be eaten quite rapidly. So instead, this relevancy system allows to prioritize. So when some of the players are very far away, the system might send them might update them quite. It might update them quite infrequently in those players that are far away. I hope this description made sense. All right, and the replication actually has different features. So first is creation and destruction, which means that basically by just enabling this replicates checkbox, it enables this feature by default. It's handled by the Unreal Engine, and it means that whenever the object is spawned or destroyed on the server, it will automatically get spawned and destroyed on all clients as well. So pretty much this object will exist similarly on both the client and server, and you as a developer don't have to do anything with it. Secondly, movement replication. So this is this third checkbox. So when you check this one, it means that the server also automatically replicates the location, rotation, and velocity. So the position and movement of the actor will also be synchronized, and Unreal Engine will deal with it itself. The third one is variable replication, and this one you can use yourself. So any variable that is set to replicate will replicate or change whenever the value in the server changes. So if you make any value replicating, then and it changes in the server, then it will always reflect to all the players when the change happen. The fourth is component replication, and this means that actor components all replicate as part of the actor that owns them. So you can also set the components to replicate, and then they are as part of the actors. And final feature is using remote procedure calls, or RPCs in short. And these are like spatial functions that are transmitted to specific machine in a networking game. So these are like your own events that you can define, and say in which machine you want those calls to be executed. All right. So as a client server system, that's where we have the authoritative server, a very important concept is called ownership. And pretty much what we want to do is that clients that are connected to the game, they have only like direct control over their own controlled things. So pawns in network game are all owned by player controller. So you as a player, you have your player controller, and with this player controller you can possess a pawn, and by possessing it you're owning the pawn. So you have the say about what you want to do with the pawn, and the server accepts it. Anytime that pawn calls a client only function, it will be directed only to the owning player's machine. So there is a client only function, and when pawn calls that, this function will only be executed if this pawn is owned by this player. And actors that have their ownership set to a specific pawn belong to that pawn's owning client. So similarly to how player controller can like own a pawn, also the actors can have owners, and some actors can be owned by pawn, where the player will then have an authority over, or like not authority but ownership over those actors as well. So pretty much through the pawn, the player can also get the ownership of some of the other actors. And finally, if you want to make sure that if something is owned by you, or better say, if you are in some kind of if you are writing some blueprint, and if inside the blueprint you want to check if this object is currently owned by this this client, then you can just use the is locally controlled node, for example. So at any point you can check inside blueprint whether this actor is owned by this client or it's not. All right. Another concept is variable replication. So any variable that's inside your replicating actor, you can set to be you can set the replication of this variable. And there are two options. So one option is replicated, and the second option is replicated notify. And they both do the same main thing. So those booleans will automatically change when they change in the server. However, the replication notify will in addition call the corresponding function. So whenever you choose this replicated notify option from the top drop down, it will automatically give you on replicated my boolean or on replicated and the variable name function, and it will be triggered whenever the variable is updated. All right, and then the final concept is called remote procedure calls, and these are the custom functions that can be called from many machines, but will direct their implementation to happen on a specific machine. So here under the if you create any custom event, under the graph settings you can check whether it's not replicating, it's multicasting, running on server, or running on owning client. And this is what it does. So when you choose run on server, it will be called only in the server. So this procedure call will be directed to the server, and of course you can only do it in the owning actor. So clients can call this server event, but they can only do that if they are owning the actor. Otherwise, well, they don't have the control over it. They can't call any function. Secondly, it has run on owning client. In this case, it's this is something you should you should call from the server, and this will direct the procedure call back to the instance in the owning client. So owning client will execute this event. And the third form is net multicast, and this means that this is also something that you will call in the server, and then it will be executed on all the clients that are connected to the server, as well as the server itself. So pretty much sent to everyone. All right, and however, the remote procedure calls are quite handy, and you can probably do almost anything you want with them. So you can just send messages between clients and servers, and multicast them to all the other clients. They are not still not like the silver bullets, and you should still not forget that there are variable replication as well, because even though you can sometimes do everything with RPCs, if you can use variables instead, then they are strongly preferable. So you can use the variables and sometimes just change the variable and use the rep notify instead, and this will actually perform much better. And also it might solve a lot of your own problems later on. So for example, one of the main thing, it will also keep like the variable state. So in case your game is like running for a while, and then you're sending some state about some booleans, for example, and then later on another player is connecting to the game, then at the beginning of when the new player connects, the server will send all the values of the replicated variables to the player. So if you're using if you are using a variable and notify function, then this new player who just logged in also gets the boolean value. However, if you if you just send this kind of boolean values with events, all the other new players who connect, they don't get these boolean values by default. So you as a developer, you have to make sure that the server also sends the boolean values to the new connected players, and overall using the variable replication is quite an useful thing. And yeah, it also runs faster and is more performant. All right, so where to learn more about Unreal Engine, multiplayer in Unreal Engine. And so previously I've also linked the Unreal Engine own documentation, where the first information was came from. But another source that's quite highly praised is Unreal Engine networking compendium. So it's like a boiled down manual of how to use all the different networking systems in Unreal Engine, and it gives a very compact descriptions with some examples about a lot of different things, and also a little bit about advanced things. So if you're getting stuck somewhere, then I oftentimes recommend you to refer back to the networking compendium, because it has even saved myself in the past when I implemented some feature for like a week, and then I discovered that there was this networking compendium that said that there was a much easier solution for the same issue that just took 15 minutes to do, and that was it. So that's a good source of reference. And one very nice illustration from the networking compendium is actually how the Unreal Engine base classes are replicated by default, because it's quite important. You're always using those base classes. So there are those main classes like game mode, game state, player controller, pawn, and so on. And now comes the real picture why all of them are necessary, and when you should use different different classes. So game mode, as we can see, in a single player game, we just added everything to the game mode, and it was fair enough. But in a multiplayer game, the game mode itself only exists in the server, and if you want to send some information to the players, you need to send it through some other classes. So yeah, it also makes sense that the player controller itself can just hold all the game rules and manage it without really having to deal with different players interpreting them differently. So instead, the class that's actually shared and replicated between the players is called game state. So game state, pretty much all the clients and also the server, every computer has one instance of game state actor, and the game mode and game has a direct reference to the game state. So whenever you want to replicate something, you have to replicate it, something based on the overall game. You have to use game state for that one. So yeah, pretty much everyone know about this game state. And previously I said that the game state is like the data container for game mode, and for multiplayer games it's quite right. So any data you want to give the access to the players or the clients as well, you should place into the game state. Then we have the player controller. Now the player controller is a little bit tricky. So the player controller is something that we only have in the server and in the owning clients. So the server has all the player controllers. He knows all about them, but the client computer only have their own player controller and nothing else. So all the other player controllers they don't know about. And this player controller, it can possess the pawn. The pawn is, well, this is a character. This is obviously like replicated. All the clients know all about all the other client pawns. So these are in the world. But yeah, the player controller, only one player controller per client exists. And then we have the player state, and this is actually where that's replicated per each like each client times each pretty much each client computer knows about all the other players through the player state, and it's also replicated through the server. So if you can see like if your game should have a list of players on the top corner, then, or player profiles, then these profiles are pretty much the list of player state or player states, yeah. And then the player states, where they are actually, or where are all the other player states, they are connected to the game state. So game state has like a list of player states. It's a list of all the other players who are connected to the game. And the player controller, well, this one has just one-to-one reference to the player state. So player controller knows only about the one player state that's the same player who's currently on the game. Well, on the client, yeah. Its own player state pretty much. All right, and finally, all the user interface actors like HUD and also widgets. These are all connected to the player controller, and they only exist on the clients, which is also quite obvious that on your client you only have one HUD for your own client, and you don't know anything about other players' user interfaces. All right, so this is like the basic architecture, and you can always refer back to it if you forgot where the things are replicated, the main classes. Okay, and maybe to better illustrate it a little bit, here's an example also from the network compendium, where you can see that we have like one server and also two players who are connected to the server. So the first player has a player controller. It has its own player controller, and also it has the second player also has its own player controller, and the players have their head-up displays, and finally the server has its game mode. And then the things that are now replicated to everyone are the game state, also the player states, and pawns. So these are the things that one will know about, and you can use to send those networked you can pretty much send data through these three sectors. All right, so that was like the main core overview of how the network system in Unreal Engine works. Well, I understand if it sounds a little bit complicated and hard, but don't worry. In the next video, I will show how to actually how these things will actually work in Unreal Engine, and you will learn as we go. So yeah, but I will continue in the next video, and until then, yeah, goodbye.